The outer edges of Mela refugee camp in northwestern Thailand. One of many camps along the Thai-Burma border, Mela is an uneasy home to thousands who have fled torture and economic hardship in neighboring Burma. Many have lived here for years off the land and in simple thatched roof huts that they make themselves. There is no electricity or running water here. But thanks to an innovative group of engineers, Mela and more than 20 other refugee camps and villages are no longer entirely cut off from the grid. Salinee Tavaranan is project director for the Border Green Energy team. BJET has installed solar panels and micro-hydro turbines across the region and trained hundreds of local residents how to install and maintain the systems. BJET works hand in hand with Taiwanese and UN-sponsored NGOs. This computer lab did not exist 2 years ago. Now refugees who once only dreamed of using computers can hone skills that will give them a fighting chance once they are resettled to third countries. Salinee is a refugee from the Karen ethnic minority. He and his family have been waiting to be resettled ever since their village was burned, and they fled to Thailand 13 years ago. Along with his father, Salinee runs the engineering study program in this lab and in an adjacent tool shop.
When we've got the solar panel, it's like we can use the electricity all day and night. So we don't need to worry about the energy to start it often. So it's very useful to run the computer all days and nights. So we can do things as we want, as well as study something in the computer anytime.
The solar diesel hybrid system installed by BJET was aimed at increasing much-needed access to computers and tools, and at cutting down on the cost of fuel and the noise and smell of the diesel generator. A row of Japanese-made amorphous silicon solar panels now provide most of the electricity. A shed full of lead-acid batteries stores the energy. BJET engineers designed the solar system so that the panel's output is channeled to a controller.
This unit is kind of the control unit to be able to work with the whole system, the brain of the unit.
That controller then feeds the appropriate amount of juice to the computers, lights, and tools. Any leftover energy is converted from AC to DC for storage in the battery shed. The diesel generator is only fired up on rare occasions now, during the rainy season, or when the solar panels aren't receiving enough direct sunlight. 2 years ago, the remote mountain village of Hue Krating had no electricity. The 200 Karen refugees of the village were almost completely cut off from the world. They had to rely on only available light to tend to their daily routine. BJET installed solar panels in the village, but it wasn't enough to furnish power to the school, medical clinic, the village churches, and meeting halls. The schools and medical clinic especially required additional light for reading and writing, and for treating emergency medical cases at any time, day or night. BJET organized a group of 40 volunteers and worked non-stop for 2 weeks to install the system from a nearby waterfall. They trudged up and down the hills and also worked with the local terrain and elements to harness the simple power of nature. and to provide the basic needs of Hue Krating village. The finished system now furnishes 3 kilowatts of power to a medical clinic, a primary school, 2 churches, and a couple of meeting halls in the village. Some homes also have enough electricity to run TVs and basic lighting.
The microhydro system that we install here, we received the funding from UNDP, United Nations Development Program, to do this installation. It's a big project and a long process. We spend about 2 weeks from the beginning until the end. There are many parties involved with this installation.
The volunteers included students and teachers from the United States, members of Taiwanese non-governmental organizations, and nearby villagers. They hauled construction material to a waterfall 700 meters above the village.
We built the dam here. It was like a natural water flow, but we make it like a big reservoir, so we can put the pipe underneath it, and we filter all the leaves or sand or little rocks over here, so we can protect whatever going into the pipe. So we put in a little bit of concrete to make it make the rock stay.
By laying PVC pipe from the water source to the penstock and turbine 172 meters below, BJET was able to engineer a design flow of 30 liters per second. Another section of piping redirects the used water back into the brook, incurring minimal damage on the local ecosystem. Electric wires also transport power from the turbine to the village below. That, says Salinee, will improve people's lives by improving the quality of education, giving light, and providing electricity to the clinic, a testimony of how simple engineering solutions can address some of our most basic energy needs.